The greatest question in space science today is whether or not we are alone in the universe.
And this month, the European Space Agency launches JUICE, a 12-year mission to see if life could exist on Jupiter's icy moons.
As scientists, we've never been more obsessed with finding alien life than we are right now.
And we're using the most advanced technology to look at some pretty weird and wonderful places across the universe.
The Sky at Night team are here each month to bring you the most exciting astronomical breakthroughs.
And we're kicking off this new series by investigating the latest science in the hunt for extraterrestrial life. I'm meeting one of the top scientists on the JUICE mission.
I cannot wait.
To discover why these icy moons are the most likely home of aliens, and what that's got to do with a game of squash.
So I think this is one of the most important realizations we've come to in the last 25 years or so.
I'll investigate what the Perseverance rover has already taught us about life on Mars, and what we'll do with its precious samples back on Earth.
Everything's different. You can never go back. People will never be able again to say, we and the Earth are unique.
Exoplaneteer George Dransfield is learning how the telescopes of the future might hunt for life on planets beyond our solar system.
And our in-house stargazing expert, Pete Lawrence, will show us what we can all see in the skies this month.
We're back.
So wrap up warm, get outside and look up, for it's another incredibly exciting year for astronomy.
Welcome to the Sky at Night.
One of the biggest mysteries that scientists have been trying to solve is whether there is life in other parts of the universe. And our nearest planetary neighbour has always been the favourite place to look.
Mars is freezing cold and has virtually no atmosphere. And it's covered in iron oxide, rust, and that's what gives it its red colour. But if you travel back far enough, we know that liquid water was running over the Martian surface. It looks a lot like Earth, and that's why for many, it is the ideal location for finding extraterrestrial life within our solar system.
Now we're getting closer than ever to finding life on Mars. NASA's Perseverance rover was launched in 2020 as one of the most ambitious space missions of all time. It landed successfully on the Martian surface in February 2021.
Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
It was the first mission to actually drill down and gather the rock of another planet for analysis back here on Earth, searching for signs of past and possibly present microbial life. One of the key scientists involved is here at Imperial College London. I've come to meet astrobiologist Professor Mark Sefton.
Why do we think we might find life on Mars?
All known life is based on water and carbon compounds, and Mars would have had those things in its early stages. And I'm a person who believes that if you have the right conditions and the right ingredients, then life is something that will naturally, chemically occur.
But what might that life look like?
Mars had a very small window in which it was quite habitable, and so it will be microbial, quite small, single cellular organisms.
So where should we be looking?
If you can find evidence that liquid water was present, then they're the places to go. And luckily, Jezero crater has all of those things. So Jezero is a hole in the ground on Mars.
Yes.
And this particular hole in the ground filled with water. And into this water came materials from outside of the crater. And we hoped that certain things were concentrated. And one type of thing is organic compounds. And that might have been packaged in just the right type of rock to allow it to be preserved over 3.5 billion years.
When you put it that way, 3.5 billion years, this is quite a challenge, isn't it?
Like any crime scene, the longer you leave it, the harder it gets. We've only got about 0.5 kilogram that we can bring back, so we've got to be very careful about the rocks that we choose.
Yes.
One of Mark's roles on Perseverance is to help decide where the rover should take its samples in the Jezero crater.
So how do you choose where the samples come from?
Luckily, the engineers don't allow us to mess around with the driving of the
Sounds
rover.
like fun, though.
So we spend our evenings in front of computer screens deciding on targets and directions. Here we have an image of Mars taken by the Perseverance rover. And so we would look at those rocks, we would look at the textures, we would look at information that comes from our instruments on board that will tell us about the mineralogical composition. And we would make comparisons with similar rocks on Earth. So these are analog samples from the Earth, but we think represent conditions on Mars. The oldest rocks on Mars have clay minerals, so similar to what we see on the base of the Jezero crater, and they represent a time when Mars was most like the Earth. So when Mars evolved, it lost its magnetic field, started to lose its atmosphere, things started to dry out and become more acidic. And we look at these rocks to try and help us understand the sort of middle age of Mars. So it's in the oldest rocks we are most interested, but we still hold hope as the rocks get younger and younger.
Images like this, I think, are fantastic, because it almost feels as if you could almost put your hand in. Would you go to Mars if you had the opportunity?
I'd send a PhD student.
A few months ago, the rover completed its rock depot, a series of 10 tubes on the ground containing the precious samples. They won't return to Earth until 2033, but Mark's team are already honing their analytical skills. Getting hold of a sample will be highly competitive, and even he isn't guaranteed to get one.
So what sort of analysis that you want to do will confirm that there might have been life on Mars?
We use instruments like mass spectrometers that tells us the structure of the molecule, and we'll use the ratio of heavy carbon to light carbon to tell us whether these compounds have been generated by life or by some non-life process. And so these become very diagnostic fingerprints of life. Wow. And so when we see them, we know the organism that generated them, and we know the environment in which the organism lived. And so it gives us an ability to reconstruct a whole ecosystem from one small drop of extract from a Martian rock.
How do you think the world would feel if we got confirmation that, yes, there was once life on Mars?
Everything's different. You can never go back. People will never be able again to say, we and the Earth are unique, because life will have been a universal feature.
I've always believed that there's life out there in the universe somewhere. It's a numbers game. With 300 billion stars in our galaxy and approximately 200 billion galaxies out there, why would life just occur here? But the challenge with the Mars sample return is that any life that is preserved on Mars will be over 3.5 billion years old. Will the evidence still be there?
We've always considered Mars the most likely place to look for life beyond Earth because it's the most Earth-like planet in the solar system.
But that now seems like a failure of imagination. There are plenty of possible habitats for life, many of them much further from the Sun.
Take Titan, Saturn's largest moon. It has a nitrogen-rich atmosphere, just like the Earth, although it's filled with a hydrocarbon haze. And when the Huygens probe descended through these thick orange clouds, it revealed a world with rivers and seas and oceans, but they were filled with methane and ethane instead of water.
Is it too much to imagine that in those hydrocarbon seas there might be complex chemistry which we'd regard as the simplest form of life?
One of Saturn's other moons, Enceladus, is a tiny, icy thing, smaller than the length of the British Isles. But there might be an even more likely habitat hidden under its surface of water ice. When the Cassini probe flew past in 2008, it revealed great fountains of water spraying from the moon's south pole. And because the spacecraft could fly through the plumes, it told us that the water was salty.
So that means that underneath the icy shell of Enceladus' surface, there must not only be an ocean, but there must be an ocean floor. which means conditions that might be rather similar to those in Earth's primordial oceans, places where many people think life got started.
It's not too much of a stretch to imagine within that strange alien ocean, hidden from the stars by an icy roof, there might be life. Bacteria perhaps, or even something more complex.
Maybe even a squid or two.
Even frigid Pluto, way out on the edge of the solar system, with a surface temperature of minus 240 degrees C, might provide a home for life. When New Horizons flew past in 2015, it showed us a world that was much more complex than many expected, with features ranging from dramatic mountains of frozen water ice to this, the so-called snail, a structure that seemed to be crawling across Pluto's surface.
The snail turned out to be an iceberg surrounded by frozen nitrogen, but the region in which it was found, Sputnik Planeta, Pluto's heart, is smooth, and that suggests the surface is fresh, with material turned over every few million years or so. The fact that there's movement suggests there's heat deep inside Pluto, and down there may be an ocean or a sea, a place where life could exist even on the cold outer edges of our solar system.
The idea of aliens in icy worlds such as these is about to be taken very seriously. After more than 10 years of development from teams across the world, the European Space Agency's Jupiter Icy Moons Explorer, or JUICE, is ready for its imminent takeoff from the launch site in Kourou, French Guiana. JUICE will search for signs of habitability on 3 of Jupiter's icy moons: Europa, Callisto, and Ganymede. But first, time for some exercise.
At first glance, Jupiter's icy moons don't look particularly habitable, but previous missions, the Voyagers, Galileo, and even the Hubble Space Telescope, have shown us that they might have some of the ingredients for life. And the explanation has something to do with a game of squash.
I'm here at Imperial College London to meet with Professor Michelle Doherty, Principal Investigator on JUICE.
So JUICE is heading to the icy moons of Jupiter. Why are they interesting?
Because we think they have liquid water underneath the surfaces, and liquid water is one of the ingredients you need for life to form.
But it's cold in the outer solar system. How is there liquid water there?
So I think this is one of the most important realizations we've come to in the last 25 years or so.
So it's
which
sort
is
of
why
squash
we've
ball
got the
like.
squash ball. The squash ball is a really good analogy for what we think's going on at Jupiter's moons. And so if you hit a squash ball really hard, it sort of heats up and it becomes pliable. And we think that's probably a similar thing going on at the moon. So as the moons are orbiting around Jupiter, their orbits are not quite circular, and so sometimes they're closer to Jupiter than others, and so the gravitational field has a different effect on the moons depending on where they are in the orbit. So that helps flex the interior.
It's sort of a tidal squeezing.
It's a tidal squeezing, and that tidal squeezing is keeping the interior warm.
Just like the way the squash ball heats up the more it's played, the push and pull of Jupiter's gravitational field on its moons heats their interiors, making it possible for liquid water oceans and potentially life to exist under the surface. It's these conditions that JUICE will investigate when it arrives at Jupiter in 2031.
Well, let's talk a bit about JUICE. It's really exciting that
is.
we're right on the edge
Cannot
of
wait.
launch. Let's skip over the boring driving bit. When you get to Jupiter, what will JUICE be looking for?
So there are 10 instruments on board JUICE. Some of the in situ instruments might measure some organic material that sputters from the surface. The remote sensing instruments will be doing a very careful view of the surface, see how it changes over time. You know, as you would expect from my perspective, the magnetometer instrument is the most important one on the spacecraft.
It's this thing, isn't it?
It's this thing here. It's on this long boom here.
So why fly a magnetometer to Jupiter, of all places?
Because without it, we'll not be able to resolve what's going on in the interior of the moons of Jupiter.
The magnetometer will measure the strength and direction of the magnetic fields around the moons. And crucially, this could reveal what's going on beneath their icy surfaces. Its focus is Ganymede, where JUICE will spend 8 months in 2034.
So you actually go into orbit around Ganymede?
It's the first spacecraft to ever go into orbit around a planetary moon, so this is really cool.
So what will the magnetometer tell us about those oceans that we think are underneath the icy shells of the moons?
Ganymede is embedded in the background magnetic field that's changing all the time. We're almost certain there's a conducting ocean under the surface, and so if you have a conductor and you have a magnetic field changing around it, that changing magnetic field generates electrical currents that flow in the ocean. Those electrical currents generate a magnetic field which we'll be able to measure. And you can work out depth, you can work out conductivity, you can work out whether it's a global ocean.
This always feels a bit like magic to me.
I know.
You don't see the ocean,
I know.
You can't touch it, it's not that you're going to land or anything, but because we're looking at magnetic fields, we can actually work out what it's like down there.
Not only that, how deep the ice crust is above the ocean. Because by looking at Ganymede, we're looking at a whole new class of planetary body called the water world. And we think lots of exoplanets are of a water world type structure. So by focusing on Ganymede, we can better understand these water worlds.
And the signals you're expecting from induced by the oceans are really small,
Very
aren't they?
small. So when I wake up at 2 o'clock in the morning and I worry about JUICE, it's worrying about whether we are going to be able to do that. And the way I like to describe it is it's like trying to find needles in a haystack, and they're changing shape and color all the time.
How does it feel to be putting this thing on a rocket and waiting for it?
Scary, really scary. And so launch will be on the 13th of April. My heart will be in my mouth. But then it will be a little bit scary for a few days after that. And then 25 days after launch, we will officially switch on the magnetometer instrument. And then my heart will be in my mouth again. You know, sure, all will be fine.
Well, let's hope it works, and let's hope we find out about these moons. Talk to you in 15 years.
Oh, really? I've got to wait that long?
Finding any kind of alien life within the solar system would surely be one of the biggest discoveries humanity could ever make. Back in 2020, The Sky at Night broke the exclusive story that Professor Jane Greaves and her team at Cardiff University had discovered phosphine in the atmosphere of Venus, a possible sign of life.
I was looking around at what you could do for the solar system and found this molecule phosphine on Earth. Phosphine is a biosignature gas.
And so a biosignature means something produced by life.
I did think, oh wow, perhaps there really are these floating microbes.
But since that groundbreaking discovery, there's been a lot of controversy amongst the scientific community.
Some scientists have argued that Venus's clouds are far too dry to facilitate life, even if there is phosphine. And others have questioned whether phosphine was really detected at all.
But we've spoken to Jane, and she has reassured us that the search for life on Venus is still on.
Her team is now monitoring the phosphine deeper into the clouds and how it changes through the day. She thinks that this change could be the reason that other people aren't detecting it. And the team argues that life could survive in tiny, self-contained environments in the cloud droplets that do exist.
While this research continues, it looks like it will be at least a few years before the controversy of life on Venus is resolved.
We're going to have to wait to discover whether or not there is life on Venus. But in the meantime, we can all get a view of the planet, as it's one of the brightest objects in the night sky right now. Here's Pete with this month's Star Guide.
This month, it's all about Venus and the dramatic scene it's going to make as it appears to go between the Pleiades and the Hyades open clusters.
On a clear night, Venus is easy to find and looks great just with the naked eye, but even better with a telescope.
You just look over towards the west, that's in that direction for me, and it's the brightest thing in the sky apart from the moon when the moon is about. Now, unfortunately, for me, the clouds have now come in, so I don't think I'm going to get much of a view of Venus this evening, but I do have some footage of it on my laptop to show you what it looks like currently. is quite far away from the Earth at the moment, so it looks quite small through the eyepiece, and it has a fairly fullish phase.
And this month, Venus can be seen alongside the Pleiades and Hyades open clusters. Open clusters are loosely bound groups of a few tens to a few thousand stars. The Hyades is the nearest open cluster to our Sun, and it's around 625 million years old, making it look large in our sky. The Pleiades cluster is located roughly 3 times further away. This and its relatively youthful age make it appear smaller. Long exposure photographs of the Pleiades reveal an elegant blue nebula. This is an interstellar dust cloud that the stars are passing through. The Hyades and Pleiades are fairly easy to find. Start by locating Orion's belt. At this time of year, it's low in the western sky in the early evening. Its 3 stars almost parallel with the horizon. Extend the line they make to the right until you arrive at the bright orange star Aldebaran. Aldebaran sits at the end of one arm of the V-shaped Hyades cluster. If you keep the line going through the Hyades, you'll eventually arrive at the Pleiades cluster. Venus passes between the Pleiades and Hyades during the first part of the month. And a couple of weeks later, we'll see a thin waxing crescent moon.
Now, if you manage to get any pictures of Venus, the Hyades and the Pleiades, we'd love to see them. Upload them to our Sky at Night Flickr and we'll pick our favourites and show them in next month's episode.
And since we've last been on air, some of you have been sending us your incredible images of the aurora lighting up our night skies across the UK.
But it's not just aliens in our solar system that scientists are looking for. The latest powerful telescopes are enabling a new generation of scientists to look for life outside our solar system, on exoplanets. One of them is exoplaneteer George Dransfield. She travels around the world in her quest for aliens in the distant universe. As part of her PhD, she's recently been in Chile's Atacama Desert to service the Speculus telescopes.
Let's meet the telescopes.
Hi, Aya.
We use ground-based telescopes like these to look for repeated dips in the brightness of stars. If a star's brightness appears to decrease, it could be a sign of an exoplanet passing in front of it. More than 5,000 exoplanets have already been confirmed to exist in our galaxy, and the real number is likely to be in the billions. The ones we're interested in finding are the ones we think could be habitable. Back home in the UK, I want to explain how we narrow down the search.
So my job is to find potentially habitable exoplanets, i.e. the ones that could maybe sustain life. And one of the ways we go about this is to try and find small Earth-sized planets because they're most likely to have a rocky surface and maybe even a thin atmosphere around this. But we're also looking for planets inside what's known as the habitable zone. This is the area around a star where the temperature is just right, not too cold, not too hot, and then we can maybe sustain liquid water on the surface.
The habitable zone is all about a planet's distance from its star.
So for the purposes of this experiment, I'm going to be the exoplanet and this here fire is going to be my host star. And my proximity to the star is going to determine how cozy I am. Right now, I'm a bit too close to the fire and therefore I am a toasty 30 degrees.
The further I am from the star, the cooler I get, and I really, really hate being cold.
And over here, it is far too cold at a 15 degrees, which I find kind of gross.
But somewhere in the middle is just right.
That's rad. Thank you.
And it's not just the planet's location that matters. The hotter the star, the further away the habitable zone is. And I want my exoplanets to be as close as possible to their stars.
So the closer a planet is to its star, the shorter its orbit, which makes it easier on us for going about discovering them. But if we also want the habitable zone to be nice and tight and close to the star, then we need to be looking for planets around cool and small stars, which is why I am searching for planets around super cool M dwarfs, as in cool in the temperature sense and also cool in the snazzy sense.
My work is in identifying these potentially habitable exoplanets. But the next stage is to find out whether life could actually exist there. I want to know how the telescopes of the future might detect alien life on these planets that we can't yet currently see. I've come to Edinburgh University to meet astrobiologist Dr. Sean McMahon. His team is working on ways we could potentially use light signals to get a closer look at life on exoplanets.
So Sean, how are you contributing to the search for life on exoplanets?
Well, what we're interested in is thinking about what the spectrum of light is going to look like that's been reflected off the exoplanets from their host stars. And then that gives us information about the composition of the materials that make up the exoplanet.
So that sounds really cool. But like here on Earth then, what is there that you could see in the reflection spectrum of Earth that's indicative of life?
This is a spectrum that we obtained just from a leaf that I picked on our way over here. And what you can see is this really sharp feature here called the vegetation red edge. When you move from the visible part of the spectrum to about 700 nanometers, which is red, and this is because of plants and green algae and cyanobacteria that need the visible light for photosynthesis. They don't need the infrared light.
Sean and his colleague Mia shine light on samples of different substances to identify the reflection spectra of biological and non-biological materials. But it'll be a long time until we're able to attempt this on the surface of an exoplanet.
How and when are you going to test this system on exoplanets?
Well, there should be a mission in the late 2030s, early 2040s, and these missions should be able to resolve direct images of Earth-like exoplanets. So that means we get a single pixel, but from that pixel you get a spectrum, and that's where all the information could be.
Okay, so talk to me about the challenges you're going to face.
Even in the best case, this spectrum that we're going to get from this pixel is going to be noisy and difficult to resolve things. And what we're trying to do in this particular research project here, avoid the situation where people say this is life because it doesn't have a non-biological explanation, by providing what the non-biological explanation might be in advance.
Look, I firmly believe that we're going to find life on exoplanets, at least within my lifetime, but we're not going to be detecting the red edge on exoplanets, at least for a couple of decades. But the work that Sean and his team are doing in mapping out false positives is absolutely crucial, so that when the telescopes and the technology are there and we're ready to point, we'll know exactly what we're looking at when we find it.
That's it for now, but do join us next month when we'll be asking the question, should we be afraid of an asteroid strike on Earth?
Until then, good night.
Brian Cox and Robin Ince are back with a witty look at the world through scientists' eyes. The new series of the Infinite Monkey Cage podcast. Listen now on BBC Sounds.